Hello everyone, welcome to Zelin's class, and today we are going to talk about a part that is very important in the calculus. So it is called the trapezium rule. Well, this part it is not very difficult to do the questions, but it is very hard to understand. So today I'm going to spend longer times on explaining these things. So firstly, now let's consider we have a graph, right? It's y equals fx. So this graph is fx. And now we have a range. Here is A and here is B. So we have a range. And now we want to calculate the area. Well, because we have learned the differentiation, right? So which means that the area is equal to the integration from a to b and then fx dx. So that is our area. However, do we have another ways to estimate the value of this? Yes, we can. Here it's a curve, right? We can just assume that there are lots of trapeziums inside. So this graph we can assume that the graph is like that. And if we assume that all the widths, so the width of the trapeziums, so the heights are h, and for those lines, for the bases, we call it y0 to yn, so like here. Then how do we calculate the area? Well, we know that the trapezium area is equal to a1, so the two bases, the sum of the two bases, so a1 plus a2 times h divided by 2. So this is the area of one trapezium. So if we want to calculate the area of that curve, we can, so firstly we change it into all of those trapeziums. And now let's add the area of the trapeziums. So it will be from, so here is y0 plus y1 times this. So this is the area of one trapezium, and this is the other, and dot 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 plus to the end. So that is the whole area of all of those trapeziums. So we can estimate, this is equal to from a to b fx dx integration. However, this is not very accurate when you're doing this, because there are, so you can see that the curve it's like, so you have some spaces around that which you cannot calculate it. However, what the idea of the calculus is, if you divide the width, the h, the width, so the height of the trapezium, if the h is equal to 0, which means that your trapezium is like very, very small, and it's almost like a line. So there are infinite, so from a to b there are infinite of the trapeziums. And if you get that, so you have infinite many very little trapeziums from here to from a to b. And now if it is like that, then you will see that there are no any, so like, estimations, so the values will be accurate because there are no more any spaces here. So the trapeziums will fill up everything in the curve if the trapezium is smaller enough. And from here we can see that the more trapezium you divide, the more accurate you are. So for example, if you have a graph and you only divide into two pieces, then it's not very accurate. No, well, actually it's very inaccurate because there is a very big gap on here. But if you divide into smaller pieces, then the areas will be small. Because we don't limit this here, so we can't really solve the exact value by using limits. So however, we can use this way, which we are we will be asked in the exams. Okay, so now let's try a question. So the question is saying that use the trapezium rule with 6 intervals to estimate that into 2 dp. Well, firstly, so we have the area here, right? The area of the trapeziums are here. And let's simplify this. So if we simplify this, so let's expand this. So we have 2h over 2 times 1 y0 plus h over 2 times y1 plus h over 2 y1 plus h over 2 y2 and plus and 2h over 2 yn minus 1 plus h over 2 yn. And you can see that for these two, it will combine to 1hy1. And so we can get hy1 plus hy2 plus n2 hyn minus 1. And what we left is h over 2 y0 plus h over 2 yn, because they don't have the pairs. So this is our formula here. So the area. Okay, so now we understand that. And for y1, it is just the value of y, because here we can assume that this is the x-axis and this is the y, well, the y-axis. So here is y, the value of y. So okay, so now let's try this question. So it says using 6 intervals. And here is 1 over 4 pi to 7 over 4 pi, which means that we should use the intervals 1 over 4 pi to 2 over 4 pi as one interval, and 2 over 4 pi, 3 over 4 pi, and 3 over 4 pi, 4 over 4 pi. So these are the intervals that we should divide into. And 4 over 4 pi, 5 over 4 pi, 5 over 4 pi, 6 over 4 pi, and 6 over 4 pi, 7 over 4 pi. So these are the 6 intervals, which means that we are going to have 6 trapeziums. And for each trapezium, the height is equal to 2 over 4 pi minus 1 over 4 pi, which is equal to 1 over 4 pi. And that is the h, so it's same in all of those 6 trapeziums. Okay, so now let's calculate the y value. So now we need to use our equation now. Our equation is, so it's cosecant, which means that 1 over sine bracket a half x. So that is our initial value. So y equals 1 over sine a half x. And now we just substitute all the values in. So we get, so if x is equal to 1 over 4 pi, then y is equal to y is equal to y is equal to 1 over sine an eighth pi. And for the second one, when x is equal to 2 over 4 pi, y is equal to 1 over sine quarter pi. And for x equal to 3 over 4 pi, y equals 1 over sine 3 over 8 pi. And x equal to pi, y equals to sine a half pi. And x is equal to 5 pi over 4, y is equal to 1 over sine 5 pi over 8. And x equals to 6 pi over 4, y equals 1 over sine 6 pi over 8. And for x equals 7 pi over 4, y equals 1 over sine 7 pi over 8. Okay, so now we obtained all seven values. And now we can apply this formula now. So which means that, so let's start a new page. So which means that the formula is h times y1 plus y2 into yn minus 1, and then plus h over 2 y0 plus h over 2 yn. And now for this case, our n is equal to 7 because there are 7 numbers here, so 1 to 7, which is 7 numbers. Well, here you need to be sure that the number of these lines are not the same as the number of intervals, because the number of intervals will always one less than the number of lines. So which means that here n is equal to 7. And what is h? H, we know that it is equal to 1 over 4 pi. So now we can obtain our results, which is 1 over 4 pi times bracket, so 1 over sine 1 over 8 pi plus n2 sine 6, well actually here is 2, and 6 pi over 8, and then plus, well, h over 2, which is 1/8 pi times 1 over sine and 8 pi plus 1 over 8 pi times 1 over sine 7 pi over 8. And now we can just calculate this by using our calculator. And let's do this. And for this, we will get 232 for this question. But this is the way of doing this type of question. So I hope you can understand that. And thank you for watching this video, and make sure to subscribe. And if you want more information, you can go to the channel by Daniel Dallas. Yeah, thank you.